Okay.
Hello again, everybody. So we're getting into more nuts and bolts and the MIG welding stuff here. And so today I want to talk about shielding gas. You know, how to handle these tanks and the regulators also. So let's just start with shielding gas. So in welding, there's four main shielding gases that we can use. Okay. Remember from my previous lessons how I talked about the cloud and all that. That's the whole purpose of the shielding gas, is to create that cloud to prevent oxidation. So we can use carbon dioxide, which is CO2. It's also what we exhale. Whenever we exhale carbon dioxide. We can also use argon, which is an inert gas that's in the atmosphere. We can also use helium. Helium is as you know, is in balloons. Helium's getting a little bit harder to come by these days. Most of the helium that was produced when we were making a bunch of nuclear weapons, and that helium supply is starting to be dwindled because we're not really making nuclear weapons anymore, which is a good thing, but the side effect is that helium prices have gone up a lot, and so we don't really use helium too much for welding anymore. And the gas that we're going to use is actually a combination of CO2 and argon, and it's called C25 because it's 25%. Boy, I should have got that right. I can't remember if it's 25% argon or 25% CO2. I'll have to check on that one for my next video. But it's a mixture of argon and carbon dioxide. And this is the one that I use at home. This is the smallest tank that we can get it in up here. The ones that we have in the shop are, you know, about triple this size as far as the actual quantity that they hold. But this little one is going to work great for being able to take home. Now, I had a bunch of videos on tank safety, so I'm not going to go into that anymore. The only thing with this one is it's under high pressure. We're talking 1,700 to 2,000 pounds per square inch. There is no cap for these smaller tanks, and the reason why is because a smaller tank, the idea is it can't develop as much inertia if it falls over because it's smaller, and the quantity in here is less, so we're still going to get a big bang if something happens here, but it's not going to be as intense as it would be with a bigger tank. It's not going to be as long. So it doesn't mean it's not dangerous. It's less dangerous than a bigger tank, but still quite dangerous. And personally, I wish these tanks had a cap on them, but they do not. So when you transport this thing, make sure that you know, when you put it in the back of your car or something, have it so that it's held again so it doesn't roll around and stuff like that. The valve on this thing is still vulnerable. The valve is still vulnerable to getting damaged, and that would be the last thing that we would want, is to have some sort of an accident with a CO2 tank. As far as when these things are upright, a smaller tank like this does not, chaining it is not as critical as it is with the bigger tanks, like I said, because they just don't develop the same amount of inertia when they fall over. However, when you do put stuff together, which I'll have in the next video, you're going to want to make sure that you have this in a place where you're not going to trip on it. We don't want it to fall over and break the regulator or anything like that. So I do recommend trying to keep it supported so that it can't fall over. Okay. The next thing we want to talk about is how we're going to take that 1,700 PSI in here and bring it down to a pressure that's workable. Okay. What we want is we're taking 1,700 pounds per square inch. We're going to bring it down to a quantity that's easy to make the cloud around the puddle, around the weld with, and not just waste the whole tank. So we're gonna take 1,700 psi and bring it down to 25 psi. Now the way that that's done is using a regulator. And Dina, you might have to get in a little closer for some of this. There's two types of regulators. They both accomplish the same thing. They just look different. And so we're going to have this type on the welder, but I want to talk about this type because this is usually the one that you run across on gas welders and a lot of MIG welders and TIG welders. So if you look here, first of all, we have our connection that's going to go, well, this one's missing our big connection to the tank. This would be our big connection to the tank right here. And then we'd have our connection going out to our welder. So we've got pressure coming from the tank going to into the regulator and then going out to the welder. So we have two dials on here. The one dial, this one, has really big numbers on it. In fact, it goes all the way up to 4,000 PSI. The other dial only goes up to, well, we have PSI on the outside and I believe kilopascals on the inside, if I remember correctly. The other one only goes up to 50, and on the PSI. Okay, so this one over here, the one with the big numbers, is telling us what the pressure in the tank is. So this is our tank pressure. This is like a fuel gauge for a car. We can basically defer how much is left in the tank by what the tank pressure is going to be. This one right here is going to be what actually is the pressure that's going out to our welding gun. Okay, so we have our tank pressure and our working pressure right here. Regulator like this. This one is a flow meter type regulator. Once again, you've got a gauge here with really big numbers on it. If you look, it goes up to 4,000 PSI on the red, and then we've got kilopascals on the outside. So that once again is going to be our tank pressure. Up here on this shaft, we have our working pressure. And so it's important that when you're setting the working pressure that you know which one you're going to use. And so here it says helium right here. And then if we move over to this side, it says argon, CF, and so forth mix here. And over here we have the same thing, the argon mix right here. The one that we're going to use is the one with the small numbers. So you can see where it goes up to 50. I think that's the side I have over there. Oh, I'm sorry. Right over here is the one we're going to use, the one that goes up to 50. Okay. Basically, the way this gauge reads is, when I move this thing, you can see there's a little ball in there, and we're going to show this on the next video. That ball will ride wherever the gauge is. The regulators are fragile. That means that if you hit them or drop them, the gauges will most likely break or they won't be accurate anymore. So handle the regulators with care, please. The regulator screws are what we use to adjust these things. So like on this one, you've got this big screw, and you can just screw it all the way out, and it falls out. And then when you screw it in, it screws against a spring, and that spring is like an adjustable valve that changes the pressure. Okay, so the further I screw this in, the higher the pressure will be, and I'm going to show you how to do that on the next video. Okay, same thing here. We've got this screw right here, which is used to adjust our pressure. Okay. All right, that should do it for this video, everybody. I'll see you on the next one.